Hello everybody and welcome to the flipped videos for the Cumulative Review number 2 packet. I'm going to be going through every question in detail, so feel free to skip around and go to the ones that you need. So if I start with the first one, number 1, I'm going to do A and B at the same time. So my degree of the first one is the highest power I see, which is 6. The degree of g of x is the highest degree or power that I see, which would be 9. The lead coefficient based on the degree would be -7. The lead coefficient based on this highest degree would be 5. The number of terms separated by a plus or minus sign in this first example is 4 terms. In this example, there are 5 terms separated by a plus or minus sign, so that would be 5 as well. The number of possible extrema or terns is the degree minus 1. So in this case, we'd have 6 minus 1 or 5 possible max terns. And this one would be 9 minus 1 or 8 possible max terns. The possible real zeros in both cases would be the same as the degree because the possible max zeros is always the highest power. So this one would be 6 and this one would be 9. The y-intercept for both is found the same way. You would plug in x equals 0 into each function. If I plug 0 into these 3 terms, I would get 0 plus 0 plus 0 minus 1. So my y-intercept would be 0, -1. In this example, my y-intercept, if I plug 0 in this term, this term, this term, and this term, I get 0, but then I get a positive 8. So my answer is 0, -8. The end behavior is sometimes the hardest part, so let me draw a picture to try to help. So when I look at this function, I notice that the highest degree is a 6-degree polynomial, which is even. So this is going to behave more like a parabola or an x-squared function. And because the lead coefficient is negative, that means it's going to be upside down or reflected over the x-axis. So if I drew a quick sketch, it's not going to be exactly like a parabola, probably have more bumps within it. But my graph would probably look something like this, where the end behavior is facing downwards in both cases. So as x goes to infinity towards the right, my y values go towards -infinity. And as I go to the left, my y values also go towards -infinity. So the end behavior would be both facing down. On the other hand, if I look at part B, my lead coefficient is positive and I have a x to the 9th is my highest degree, which means that this function is going to behave more like a cubic function, or x to the 3rd, than a parabola. And because my lead coefficient is positive, my function must be increasing from left to right. And so it would probably look something like this. Now this is not perfect, but it would probably have something going on in the middle, but it would look more like a cubic than a parabola. So my end behavior increasing from left to right would be here and here. So as x goes to the right, the y values go up to infinity. So this would be infinity here. And as x goes to the left, my graph goes down towards -infinity. So this would be -infinity here. Number 2. Sketch the graph of the following polynomial by finding the y-intercept and the x-intercepts, and I may want to consider end behavior, terns, and the multiplicity of zeros. So I think that the zeros are the most important thing to find first. So let's find the x-intercepts first, and to do that, I'm going to plug in 0 for y. So if I start this problem, my first gut instinct is to factor. And I notice that I have a greatest common factor of -x, and I would be left with x to the 4th minus 6x squared plus 9. Be careful about your signs here and here when you take out the negative. If I continue to factor, at least check to see if I can. I look at my trinomial here and notice that x to the 4th can be x squared times x squared. 3 times 3 can give me 9, and 2 negative 3's can combine to be -6. So -6 through -3 times -3, positive 9, checks out to me. So this is factored. So now to find my x-intercepts, I'm going to set all 3 pieces equal to 0. So this first x-intercept, if I divide by -1, would just be x equals 0, which really means that one of my roots is 0, 0. And so I'd graph that here on my graph. Notice that this root only occurs one time, so it has a multiplicity of 1, which means you go through the x-axis. However, these two parentheses are the exact same. So when I solve this one, I get x squared equals 3, so x equals plus or minus root 3. And if I solved this one, I'd get x equals plus or minus root 3 again. So because the roots of root 3 comma 0 and negative root 3 comma 0 repeat 2 times, both of these have a multiplicity of 2, which means on the x-axis there's a bounce that happens and it does not go through. So root 3 is about 1.73. So one of my x-intercepts would be here, one of my x-intercepts would be here. So that's at least a good starting point. My y-intercept would also be 0, 0, so that's already found. If I think about end behavior, this is x to the 5th, so it's a little bit more like a cubic or x to the 3rd function. Because the lead coefficient is negative, my function is going to be decreasing from left to right. So what my graph would look like is I would have to start up high. I would go first towards my red root. I remember that the negative root 3 has a multiplicity of 2 because it repeats twice, which means my graph is going to bounce here, come back up, go through 0, 0 because it has a multiplicity of 1, come back up to this root, bounce again because root 3 has a multiplicity of 2, and then my graph will continue towards negative infinity. So my end behavior checks out, start high and low, and my multiplicities of going through the x-axis and bouncing check out as well. Now, Ms. Schwartz and I agree that for your test, you don't need to know what these exact points are. We're looking for a general sketch, looking to see if you understand which roots you go through and which roots you bounce. The next example, similar idea, sketch the graph, find the y-intercept and the x-intercepts, and we want to think about the same things, end behavior, turns, and multiplicity of zeros. So let's start this one by finding the x-intercepts again, by setting y equal to 0. And GCF is always a good idea. I notice that there's a greatest common factor of x squared. So we're left with x squared minus 49. If I continue factor this quadratic, we'd have x times x, 7 times 7. My middle term needs to cross out, so we have one positive and one negative. So I have 3 equations to find my roots. X equals negative 7 only occurs one time, so the 0 of negative 7, 0 has a multiplicity of 1. This 0 of 7 comma 0 also only occurs once, so it has a multiplicity of 1. However, this root, if I take the square root of both sides, I technically get x equals plus or minus 0, which means that the root of 0, 0 actually occurs twice, positive and negative 0, which is sort of ridiculous to say, but this root, because it occurs 2 times, has a multiplicity of 2. So this is the root of which you are going to have to bounce. So what I'm going to do is graph these roots, 0, 0, negative 7, 0, 1, 2, 3, 4, 5, 6, 7, and then positive 7, 1, 2, 3, 4, 5, 6, 7. If I consider end behavior, I notice that my lead coefficient is positive and it is an even exponent, which means my graph is going to be more parabola-like. So I know my end behavior is going to start up and end up. So if I want to draw a sketch, I'm going to start up. I'm going to go towards the first root at negative 7. Negative 7 has a multiplicity of 1, so I'm going to go through that. I'm going to have to turn around, hit 0, 0. It bounces at 0, 0 because it has a multiplicity of 2, comes back up towards 7, goes straight through because it has a multiplicity of 1. So my graph would look something like that. Complete the division problem. Well, I notice that what I'm dividing by is x plus 3. And so when I see a divisor that is linear, is in the form x plus 3, I think that the fastest way to do this problem would be synthetic division. And so if you are dividing by x plus 3, that means that your root is actually negative 3. If I write my lead coefficients, and please be careful for placeholders, we would have 1, negative 13, 0 for x cubed, 0 for x squared, negative 120, and then 80. So if I bring down the 1, negative 3 times 1 is negative 3. Combined down is negative 16. Negative 16 times negative 3 is positive 48. Combined down is 48. 48 times negative 3 would get me negative 144. Combined down. Negative 144 times 3 is 432, positive 432. And if I combine down, I would get 312. Then if I multiply 312 times negative 3, I would get quite a big number of negative 936. So when I combine down, I get quite a remainder of negative 856. It is okay to get a crazy answer like this sometimes. So if I divide x plus 3 into this x to the 5th polynomial, my answer would be 1x to the 4th minus 16x to the 3rd plus 48x squared minus 144x plus 312 plus the remainder of negative 856 over the divisor of x plus 3. What a wonderful answer. If you are not sure on the test if this is correct, remember that you can always check your answer with long division. I know it's a little tedious, but it is an option. Or you could even take the remainder of negative 856 and you could plug it in to see if that works as well. This next problem, number 5, again, just complete the division problem. So it's your choice if you would like to do synthetic or long division. Now, we could do synthetic division on this problem. We talked about this in class, that if you do have a lead coefficient other than 1, you can do synthetic division by saying your root's 2/3, but then you'd have to divide out the 3 at the end. Just to be safe for the video, I'm going to do long division on this one because I feel like it's better safe than sorry. So 6x to the 3rd minus 16x squared plus 17x minus 6, no placeholders. All right, so if I start this problem by asking how much does 3x go into 6x cubed, or what's 6x cubed divided by 3x, that would be 2x squared. Make sure it's lined up with a like term. If I multiply back, that would be 6x to the 3rd. 2x squared minus 2 is 4x squared. When I subtract, I have to change the signs in both cases. So these would cross out, and here I'd be left with negative 12x squared plus 17x minus 6. Now for round 2. Does 3x divide evenly into negative 12x the second? Why, yes it does. Negative 4 times to be exact, or negative 4x times. So if I multiply that back, I would get negative 12x squared. Negative 4x times negative 2 is a positive 8x. And again, because I'm subtracting both of these, both of their signs eventually change to a positive and a negative. So again, this crosses out, and this combines to be a 9x minus 6. We actually can do another round because 3x does divide evenly into 9x 3 times. If I multiply back, we would get a 9x and then a minus 6. Both cases, if I change that to a minus because I'm subtracting and change this to a plus, they both cancel out, which means that I have a remainder of 0. So when I did long division, my final answer was 2x squared minus 4x plus 3. Okay. This last problem here, you're going to have to do long division because what you're dividing by, this divisor, is quadratic. The only time you can do synthetic division is if this bottom piece is linear. So I'm going to write a note that we're going to have to do long division. So at the beginning of the next video, I'm going to start with this problem and go through my steps. All right, guys, I'll see you on video 2. Thanks.